Hi, and welcome to a Rambalidi-doo. What is that? What even is that? Anyway, I am currently procrastinating, and usually my go-to is to come here and do some high school math problems. But I'm not in the mood for an exam, you know? So I'm going to do something a bit different, and this is really me just having fun as opposed to really like being a contributing member of society. I am going to work through a grade 8 South African mathematics Olympiad paper. I'm hoping I haven't seen this one yet. I don't think I have. I'm seeing previews. I don't want to see previews. Yeah. I recently worked through the 2023 one. I thought, that was so much fun. So I am going to do the 2024 first round. And I'm going to try and do it in the time allocated. The babies get 60 minutes. So me, as a whole grown adult who has a matric, who has a bit of university level maths, even though I don't really remember a lot, if any of it, hypothetically, I shouldn't take the full 60 minutes now, should I? But we're gonna see how well this 30 plus brain does. And by the end of this, I might just have a newfound level of respect for the kids that brave this, let alone excel at it. So yeah, because I'm going to be chasing time, I'm not going to be as detailed in my explanations. Some of my explanations are probably just going to be left at intuition level with absolutely no mathematical justification. And maybe then I'll do a follow-up video for questions that piqued my curiosity a bit more. This is no calculators, no geometry instruments. Wah. Okay, so I'm literally gonna have the timer nearby and just, after the 20 questions, see how did I clock? So I really didn't want to see any of the questions beforehand, so I haven't even prepared the document. So I'm gonna trust my post-production skills to shimmy the questions onto the page afterwards. Right, I don't know why I'm giving all that detail. Maybe it's the nevs. Okay, let us begin. Timer. Boom. Okay, right. Question number 1. So we have 2 plus 2 to the 4 times 0 plus 2 times 4. Okay, so I've got, this is my first term. Oh my goodness. And that is my next term, and that is my last term. So that is 2 plus 0 plus 8, which is 10. Is that one of the answers? Yes. So my answer for that is E. Okay, on to the next one. Nice little warm-up there. Right. Next question says, how many different prime factors does 360 have? Okay, so 360 is the same as 36 times 10, which is the same as 4 times 9 times 2 times 5. Okay, so I've got 2 squared times 3 squared times 2 times 5. So that's 2 to the 3 times 3 to the 2 times 5. So it's got 3 different prime factors, 2, 3, and 5. And that is A. Okay, so that's my answer for that one. Right. Okay, next one. If 15 by 15 by n is equal to 30 by 30 by 30, what is the value of n? Okay, so 30 is 15 times 2, and we've got 3 of them, right? So that is the same as 15 times 15. Okay, how do I want to do this to make it make sense to myself? So I don't want to write it like that. I instead want to write it as 15 times 2 times 15 times 2. Right, so I want to write it out expanded. So I've got the 15 times 15 here and the 15 times 15 over here. So the n must be the rest of the stuff. The 2 times 2 times 15 times 2. And what is that? So n is equal to 2 times 2 times 15 times 2, which is 15 times 8, which is 120. So D. Okay, next one. What fraction of the rectangle is shaded? So we have a rectangle. Pretend that's a rectangle. There's a diagonal drawn in, or both of them drawn in, and then they've shaded this part over here, which is a quarter. It's not a quarter. It's not a quarter of the rectangle. And then they've also shaded this part over here. Okay, so it is half of the triangle of the rectangle, half the rectangle minus whatever portion of the rectangle that is. Okay, so let's see. If this is the breadth, B, then this is half of the length and half of the length, and this is half of the breadth. So the full area, the area of the whole rectangle, is B times L. Then the area of, I don't really care. Okay, I want to work out the area of this part, which will be, so the area of purple will be half L times half. It's a triangle. Oh my goodness. Okay, so sorry. It's not just going to be length times. It's going to be half base times height, which is 1/8 of LB. Okay. So something tells me that, okay, yeah, I guess. So this, okay, I'm not over-explaining. This would be half L, half B. So all these little triangles are going to have the same area, really. Okay, anyway, so I didn't really need to do all of this work. So this is just going to be 3/4 of a half, 3/8. Yeah, because it's 1/8, 2/8, 3/8. But anyway, let's commit to the cause. So the area of the shaded part, well, the blue part, will be BL minus 1/8 of BL. No, it's not BL. Okay, the area of the shaded part will be a half of BL, because it was just this half of the rectangle minus the 1/8, which is 4/8 minus 1/8, which is 3/8 of BL. So 3/8 of the rectangle is shaded. T. Wow, that was very long-winded. Right, next question. If a person works for 8 hours every day, for how many years would they have worked in total over a 24-year period? Ooh, I was about to lose it. Okay, so I thought we were going to do a whole lot of multiplications, but no. They work for 1/3 of a day, every day. So in 24 years, they will have worked 1/3 of that as well, right? 1/3 of 24 years, which is 8 years. C. Right. If the square root of x is between 9 and 10, then the cube root of x is between a what? If the square root of x, if the square root of x is between 9 and 10, so that means x is between 81 and 100. So then the cube root of x is going to be between the cube root of 81 and the cube root of 100. Definitely cheating and using higher level maths here. 81 is the same as 3 to the 4. And 100, I can't really, but this will be 3 times the cube root of 3. Okay, so maybe this isn't useful. I'm doing the thing that I shouldn't do. I'm erasing. Okay, what are the cube numbers? 1, 8, 27, 64, 125. So the cube root of 81 is somewhere between 4 and 5. The cube root of 100 is also somewhere between 4 and 5. So the cube root of 81 is bigger than 4. And the cube root of 100, right? Both the cube root of 81 and 100 is between 4 and 5. And if x is between the cube root of these guys, then very broadly it's between 4 and 5. So I'm going with A. Right. Next one. If a fifth, okay, time to use a less abrasive color. A fifth is smaller than d over 30 is smaller than a third. How many possible integer values are there for d? So I want to put these all over the same denominator. So thankfully 5 and 3 both go into 30. So this is 6 over 30 and this is 10 over 30. So if d over 30 is between these two, d is either 7, 8, or 9. So there's 3 possibilities. Integer values. Right. If A star B means A minus 3B, then determine the value of 20 star 2 star 4. Okay, so first let's work out 20 star 2, which will be 20 minus 3 times 2. Okay, and then we're going to take that and star it with 4. So that will be 14 minus 3 times 4, which is 2. A. Okie dokie. Going swimmingly. Right. Mary and Sisanda share sweets in the ratio 4 to 9. If Sisanda has 15 more sweets than Mary, love these kinds of questions. How many sweets does Mary have? Okay, so Sisanda has 5 parts more than Mary, and we're being told that those 5 parts are equivalent to 15 sweets. So 1 part is equivalent to 15 over 5, which is 3 sweets, and therefore Mary has 3 times 4, which is 12 sweets. Right, and indeed, if we check, if this is equivalent to 12 sweets, and Sisanda has 15 more, so that is 27 sweets, and 12 to 27 simplifies to, if I divide by 3 on both sides, does simplify to 4 to 9. Awesome. So Mary has 12 sweets. B. Okie dokie. Consider a brick, a rectangular box measuring 10 centimeters by 15 by 20. by 15 by 20 centimeters. Okay. What is the smallest number of bricks that can be packed together to form a solid perfect cube? Oh. Okay. So we, me and 3D thinking, tsunami. Okay, so we either want to, okay, let me just draw this out while I think. So if we had one of these bricks, so that would be 15, and then we could keep packing them, so that would be another 15, and we'd have to pack them until, okay, so we're looking for the lowest number that 15 and 10 can both go into, which is 30. Perfect cube. Oh, we're not just thinking about one dimension, think about all three. So a number that 10, 15, and 20 can go into, so that'll be 60. All right, so we'd have 4, and then 6 going up. Oh, am I really going to draw all this? And then 3 going this way. Oh, horrible drawing. Okay. Yeah, so then we'd have 60 centimeters here, another 60 for depth, and then going up another 60. So how many cubes is that? So that's 4 by 3 by 6, which is 72 of them. D. Okay. I just love how I am not even really like pausing to. It's the pressure of the exam. A piece of string is cut into smaller sections by using horizontal lines. If 2 horizontal lines are used, the string is cut into 7 pieces. What is the smallest number of horizontal lines needed to cut the string into 40 sections? Hora. Okay, so this string looks like this. Okay. So, if we cut once, the maximum number of cuts we can make, this wouldn't maximize, it would have to be here. Whoa. So the maximum number of cuts we're making there is 1, 2, 3. Okay, so 1 line, 3 cuts. Okay, and then maximize with that line. How'd you get 7? Oh, pieces. We're counting pieces. Oh. Okay, right. So with 1 horizontal line, how many pieces do we get? We get 1, 2, 3, 4. 4 pieces. Okay, right. And then if we add another horizontal line, then we get 1, 2, 3, 4, 5, 6, 7 pieces. 2 lines, 7 pieces. Okay, if we then add another line, then we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces. Okay, so with each line that we introduce, we add 3 more pieces. That makes sense to me. So now we want to get 40 pieces. So if we have L lines, how many pieces do we get? It's going to be 3 times L, so that would be 3, 6, 9, and then we add 1. Okay, so that'll be 3L plus 1 pieces. So we need to figure out, when does 3L plus 1 equal to 40? So that'll be 3L is equal to 39, and L is equal to 13. So we need 13 lines. A. Okay. Right. 12. The 3 digits of a 3-digit number add up to 25. How many such 3-digit numbers are there? Oh, I kind of know this from, oh no, I don't. I was gonna say from playing Kakuro and Killer Sudoku, which are such fun games to play. But they didn't say that the 3 digits are unique. So from playing Kakuro, I know that if they were unique digits, it would only be 7, 8, and 9. But here, it could be, 999. That doesn't add up to 25. Okay, so I'm going to start by saying, if we just look at 2-digit numbers, right, 9 plus 9 is as high as we're going, which adds up to 18. So that already disqualifies certain numbers from appearing in our 3-digit number. Because if we added a 1 there, it's not going to get us to 25. So 1, 2, 3, 4, 5, 6 are all disqualified because, even 6 plus 9 won't get us to 25. So we're only looking at the numbers 7, 8, and 9. Okay, 7, 8, 9. And now I'm just going to do some manual counting. So if we have 7, then we need 18 to get to 25. So that will have to be 9, 9. And that's the only possibility. Next, if it starts with an 8, then we'll have to consider how we can mix these around. Okay, so right now we're just looking at combinations that work. If it contains an 8, in order to get 25, we'll need another 17, which we can only get by saying 8 plus 9. Yeah. And then if it contains a 9, I think we're going to end up with these 2 combinations. But anyway, if it contains a 9, then we need a 16. And we can either get that with 7 plus 9 or 8 plus 8. So already accounted for. Okay, so now we need to think about how many different ways we can arrange this into 3-digit numbers. So the first one is obviously 799. Or we could move the 7 into the middle, or we could move the 7 to the end. So the 7 is really the kingmaker here. Then for this combination, we can have 8, 8, 9, or the 8 could be in the middle, or not the 8. The 9 can be in the middle, or the 9 can be at the beginning. So there's 6 numbers. 6 such numbers. B. Okie dokie. Right. Then we have a diagram that I am going to redraw terribly. Oh. Oh, now when I need this, now when I need you. Sometimes technology, sometimes the AI. Hey. We're working out x. I will confess that I did a question similar to this in the 2023 paper, and it absolutely whooped my behind. Okay, so these are all 1, 2, 3, 4 straight line segments. Determine the size of the angle x. Da 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 ba 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 da ba da ba 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 da ba da ba 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 da ba da ba ba. Okay, so I'm just going to start drawing. This is deceptively looking like a 90-degree, but I mustn't allow myself to believe that it is. 40, 30, 110. Oh, so this is 50. Okay, so angles on a straight line, 60. Angles on a straight line, if we draw that, 30 over there. Angles in a triangle, so this is 110. Exterior angle of this triangle, 60 and 50, will give me 110. Okay, so that's my answer and I'm sticking with it. Until it's not one of the options, then that's just so awkward. Okay, so that is my answer for E. Not for E. For number 13, my answer is E. Ugh. You know, I watch some of my videos, only some of them. I should watch more of them. And I say things that my brain is not thinking. Hashim plays 3 games of cricket and scores an average of 50 runs. Okay. What does his average need to be for his next 3 games to raise his overall average to 60 runs? Oh, golly golly. Okay, so for his first 3 games, the average is 50 runs. So that means in total he did 150 runs, right? And then we need to add, we need to add however many runs, so that over the course of 6 games, the average comes to 60 runs. So we need 150 plus x to be equal to 360. So x needs to be equal to 210. So his average for his next 3 games needs to be 210 over 3, needs to be 70 runs per game. Right, and that is D. Okay, right. Next one. It's a spatial something. My brain hurts. The net shown. How are we doing for time also? Okay, almost halfway. And almost 3/4 way through the paper, so that's cool. The net shown below is cut out and folded to form a cube. One face of the cube will have the letter F on it. What letter will be on the opposite face? Okay. And that's already not really giving cube. Yo, gets worse and worse. The worser and the worser. So we've got F here, E, D, C, B, A. Okay, the net shown is cutted and folded. Wow. One face of the cube will have the letter F on it. What letter will be on the opposite face? Okay, so if we start out with the F here, okay, then this guy is going to come here. Okay, so the DC will be like this now. So then I can flatten the D onto here. I'm not sure what the orientation will be. I'm not really invested. And then the C will be here now. Where's the B? Where's the B? Where's the B? Okay, I am kind of invested in the orientation. So yeah, the D will be like this. like this. Okay, which actually means, what am I saying? So the C will actually be here. The C will be there, and the B and the A will be there. So yeah, the B is going to end up on this side. The C comes flat down here. Wait, the B... Okay, so I'm saying C is at the back, so that's what I really care about. But now I'm invested in where the B goes. So the C would come down. Ooh, my brain. My precious brain. Okay, right. No, not right. The C would be here. Oh, okay, then we'll come down, and the B will fold alongside here. Yeah. Okay, so the C would be here. Okay. Like this. And then the B and the A would be here. Okay. Then we put the C down, so it's going to come here. It's going to look like that, I think. Right? And then the B would have to, well, yeah, guys, this is hurting my brain so much. So the B and the A would do that, right? I don't even want to imagine what orientation it is in right now. I think it's something like that. Okay, I'm not going to figure it out for the A. Okay, and then the B would then close onto the side like this. Okay, and the A would still be flapping down. Okay, and then you'd bring the A up. Okay, right, so opposite to the F will be the C, which is option C. Okay, right. On to question 16. A certain month with 30 days has 5 Sundays. Ooh, spooky. It's not spooky. The 5th day of this month could only fall on which one of the following? Okay. So if it has 5 Sundays, the only way that can happen is, because, okay, it's got 30 days, so 28 of the days are in like full weeks. So it is then either, the situation is either that so we either have the situation where, okay, so here are the full 4 weeks here. All right, we're just gonna name the full weeks. Okay, then it's either we have, okay, and I'm gonna say Sunday, Monday, blah 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 up until Saturday. Okay, so either the month starts here, because then we'll have the 8, the 15, the 22, the 29. Okay, so that would be a situation where we're starting on a Sunday, or we're starting on a Monday. No, that wouldn't work, because then we'd only have 4 Sundays. Yeah, that wouldn't work. Yeah, so it would then also, when else would it work for us to have 5 Sundays? It would have to be the situation where, so we want these ones. We want these Sundays. So it's either then the 5th Sunday is here, in which case the month is starting on a Sunday, or the Sunday is here, in which case the maximum number of days that can follow it. So it's either this is the last day of the month, because we have 30 days, 28 days in a full week. So the other possibility is that the month is ending here. So then we've had the 28 days here and then 29, 30. It can't be here. It can't end here, because then there wouldn't be enough days to make full weeks. Why do I care about the full weeks? Oh, because we definitely want these Sundays. Okay, so these are fixed. Okay. Yeah. So these are the situations, right? Either the month starts on a Sunday, then we get our 5, or the month ends on a Sunday, in which case, when did it start? So that would be, it would start on Saturday. Yeah, because these are our 28 days, and then those would be the 2 remaining days. So it's either starting here or here. Or if the month ends here, then it has to have started. Okay, yeah. So it's either then the month is starting on a Saturday or a Sunday. The 5th day of the month. Oh, God. Okay, so we're either starting here or here. 5 days from Saturday is Saturday, Monday, Tuesday, Wednesday, Thursday or Friday? Thursday or Friday? D. Oh, where am I even going to put the question? Aye. Okay, right. Definitely need to rethink this on a future run. Right. Owami lights a candle every 12 minutes. She's Owami. Each candle burns for 45 minutes. How many candles are burning 1.5 hours after the first candle was lit? Oh. Owami. Beautiful name. Lights a candle every 12 minutes. It's also time for a change of color. Okay, so we start at T0 with candle number 1. Yeah, I'm going to name them candle number 1. And then 12 minutes pass and we have candle number 2. And then 12 minutes pass and we have candle number 3. Candle number 4. Candle number 5. So in between here is 12 minutes. And so it goes. Okay, right. Each candle burns for 45 minutes. Okay, so we have candle number 1 burning until somewhere here. Okay, so that's candle number 1's 45 minutes. And then candle number 2 will burn until somewhere over there. Candle number 2, 45 minutes. I mean, I feel like I'm answering the question visually, like by brute force, because what is clear to me, 1.5 hours? Oh no, 1.5 hours is 90 minutes. Oh goodness. Okay, I'm not going all the way there. We definitely need to find a pattern. Okay. I'm just gonna find the pattern of when they stop burning, So candle number 1, no. Yes. Okay, so 45 and then plus 7, 52, 57. So this is me writing down after how many minutes relative to T0. If T0 is here, then candle number 1 will stop burning after 45 minutes. Candle number 2 will stop burning after 57 minutes relative to the very beginning of this endeavor. The next candle will stop burning at 69 minutes, right? And what we want to know is how many candles are burning 90 minutes after the first candle was lit. So we want to know how many terms of this pattern, are greater or equal to, no, has to be greater than 90 minutes. But what's the upper bound? We can't start, well, we want to know what do we want to know? Let me just carry on with my little pattern here until I hit a light bulb or a candle. At 90 minutes, when we get to 90 minutes, how many candles are still burning? How many candles are burning when we get to 90? How many have started prior to the 90? So before the 90, we've lit, so every 12 minutes we're lighting. So at 0 we light, at 12 we light, at 24 we light, at 36 we light, and so on. So at 90 minutes we have lit 12 goes into 90 how many times? 7 and a bit. And then including the one that we lit here, we have lit 8 candles in total, right? Yes. The most recent one will be the one that was lit at the 84th minute, and that will be the 8th candle, right? But then we need to minus now the ones that have, faded, which is 1, 2, 3, 4 of them. The next one is literally gonna go out 3 minutes after the 90 minutes. So there are 4 that are burning at 90 minutes. C. Right. Okay. 3 questions to go. You can do it, little brain. 2 athletes run towards one another. They're meant to be each other. On a straight stretch of road, one athlete runs at a constant speed of 6 kilometers per hour, while the other runs at a constant speed of 9 kilometers per hour. What is the distance between the 2 athletes 1 minute after they meet each other? Nine kilometers per hour, 6 kilometers per hour. Okay, first of all, when do they even meet? Don't know what is the distance between them. 1 minute before they meet each other, even. Okay, so I'm just gonna say then the distance between them is D kilometers. Okay. And let's say they meet after T hours. Okay. So that means that 6 times T plus 9 times T, so I don't even need the D actually. which is 15t, is the distance between them. Okay. kilometers. Okay. So we want to know the distance between them. What? The distance between them 1 minute before they meet. So I'm going to work out how much they will have covered in that time. So a minute is a 60th of an hour. So 6 times a 60th of an hour is a 10th. So that's 0.1 kilometers. That's what runner number 1 will cover. And 9 times a minute, 60th of an hour. 9 over 60 is 3 over 20, which is 0.15 kilometers. So that is the distance that this one is going to cover in a minute. And the distance that the other one will cover in a minute. 1 minute before they meet each other. Yeah. Okay, so actually this whole spiel wasn't even necessary. We just need to know in that last minute before they meet. Hey? Really? Yeah, that makes sense to me. It's just about how much distance they cover in a minute. Never mind the whole context of... Yeah, because they're gonna meet somewhere. A minute before that, this one covered 0.1 kilometers to get there, and this one covered 0.15 kilometers to get there. So what is the distance between them? So that is 0.1 plus 0.15, which is 0.25 kilometers. E. Okay. Number 19, a semicircular arch. Yo, am I gonna redraw this really? I don't want to do it. Is made from identical isosceles trapeziums. Okay, isosceles trapezium is what is? These two are equal. What is the size of the angle marked X? I don't know what can I do with myself. I don't know what can I do with myself. I don't know what can I do with myself. I get to be We also know that the sides are parallel. What a joke. Right, so I mean, definitely the 100% going to abuse some grade 10 knowledge or something, because if I divide these, then okay, these two are equal. Ring. What is it? Alternate angles. So these are equal. Oh, these are equal. These sides are equal. And then there's a common side here. So are these congruent? We have side, 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 angle, angle, side, side, angle, side, or RHS. Nope. None of those are met. Which really does kind of make sense. Like, these are not equal unless, you know, we're looking at a more specific trapezium. parallelogram, etc. Okay, so yeah, not abusing my higher level mathematics just yet. I mean, I think there's a significance to it being a semicircle, right? Okay, we will come back to this one. Let the brain simmer on it. If two different numbers are randomly selected from the set 3, 4, 5, 6, 7, 8, then what is the probability that their product has exactly 4 factors? Okay, brain broken. What are we saying? We choose two different numbers. What are the chances that their product has exactly 4 factors? Okay, so let's say we chose 3 times 8, which is 24. This definitely has more than 4 factors. The factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. So, no. Okay, 3 times 5 has the factors 1, 3, 5, and 15. Okay, so that would be one of them. Okay, so what are we looking for? It has to be so I just feel like we can't use, yeah, okay, so it has to be a product of two numbers, two prime numbers. Yeah, because then the factors of that number will be the two prime numbers, 1, and the number itself. So 3 times 8 doesn't work because already from 8, the factors of 8 are 1, 2, 4, and 8. So if you times that with any other number, then you're over 4 factors for whatever the result of the product is. Okay, so it's either then we have 3 and 5, 3 and 7, or 5 and 7. These are the only prime numbers in the mix. Yeah, because now if we bring in 6, it has the factors 1, 2, 3, and 6. If you then times it with 3, for example, then we can combine the 3 with any of those 1, 2, 3, 6 to create more okay, yeah, so has to be two prime numbers. Okay, so how many products are possible to begin with? Or how many pairs rather? So you are timesing, you have the choice of 6 numbers and 5 numbers for the second number, but we are double counting because 3 times 8 is the same as 8 times 3, so we don't want to count that twice. So that's 15 possibilities. So 4 factors, exactly 4 factors, that's a chance of 3 out of 15, which is a fifth. E. Okay, right, so back to our semicircular arch. Oh. My brain, my brain, my brain. Oh, messages. Okay. How are we doing on time? 8 minutes to go. I'm so blank. blank, blank. So, I mean, are these symmetric isosceles trapeziums? I suspect they are. If I split it right down the middle there, and where's X? Oh, I've even flipped it around. I think this is X. I don't think so. I don't think they have to be symmetric. Oh, but in order for them to be, these two lines to be parallel, I can't see a scenario where this arm goes at a different angle to this, and these two lines are still parallel. Like if I were to take this arm and swing it out a bit, then they'd have to join here and these two wouldn't be parallel. So I am going to go right ahead and say that this is also X. So it'll be little x's all around. And does that help me with anything at all? So I mean, if we were to extend each of these trapeziums, so then we have 180 minus x, 180 minus x, isosceles triangle. Here would be, this adds up to 360 minus 2x, so this would have to be, how do I get this to be 180? 360 minus 2x plus something needs to give me 180. So I need to minus 180 and, does that even make any sense, girl? Minus 180 and then minus 2x. A joke. That is what is up. Oh, it's plus. Sorry. Okay, right. 360 minus 180 is 180 minus 2x plus 2x cancels out. Okay, so this would be 2x minus 180, right? And what I am curious about is whether these triangles would all fit nicely, converge nicely, there by the center of the circle. I mean, they'd all have the same length, and by definition, a circle is just the collection of points that are the same distance from some other point that we call the center of the circle. So if we have all these triangles sitting next to each other with the same length, the same, these sides being the same, it makes sense to me that they will all converge at one point. In which case, this times however many triangles we get, let me count quick, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times this should then give me 180 degrees. So 2x minus 180 would need to be 20. So 2x is equal to 200, and therefore x is equal to 100. B! 3 minutes to spare! Okay, let's mark. Mark and weep. Mark and weep. Where are the solutions, my friend? So first one, we got E, yes. Second one, A, yes. Third one, D, yes. Fourth one, D, yes. Just gotta vary the pitch. C, yes. Okay. Next one, A. Next one, B. Next one, and of course, like if I see something that stands out for me in the solutions, I'll pause. A. Following one, B. Okay. Sorry. So what was interesting here was that they actually did it like with x's. So they said the ratio of x over x plus 15 must be equal to 4 over 9, and then solving that. Next one, D, using lowest common multiple STIRF. Indeed. Ah, my masterpiece. The following one, I got A. Right, so also looking at it using patterns, yeah. Following one, B. Yeah, similar approach as well. Okay, next one. So they drew a parallel line here and worked from there. Not very invested. Okay, so with the parallel lines they were able to get that angle and then this angle and then figure out that angle and that angle, and then okay, cool. But yes, we both arrived at E. Okay, and then D for the next one. Right. Oh, this one that just caused me all the grief in the world. It would be so painful if I got it wrong. Oh, so they're so clever about it. So they say opposite faces of the cube cannot share a vertex or an edge, and C is the only face that fulfills that condition. Okay, but you still had to like fold it mentally to arrive at that. Yeah, okay, anyway, but that's a cool explanation. Right. Next one. Yo, guys, I got D, they got C. Oh, yo. If the month has 30 days and 5 Sundays, then Sunday must either be the first or second day of the month. Oh, valid. Absolutely valid. How did I have it? Yeah, okay, I thought about it with end of the month. Ah, what's happening? Yes, but it's either then, yeah, that's such an easier way to think of it. How did I think of it? So I said either we're ending here or here, which is inaccurate. How did I think of it that way? Okay, It's definitely easier to think of it as Sunday being okay, but I think I did eventually arrive at either the month is starting on Saturday or the month is starting on Sunday. Yeah, we agree with that. As for okay, let me not diss myself. Okay. Right. If the first day of the month is a Sunday, then the fifth day will be a Thursday. Yes. So Thursday or Wednesday. No? Wait, from Saturday? Let's count days, guys. Saturday, Sunday, Monday, Tuesday, Wednesday. So 1, 2, 3, 4, 5. Or 1, 2, 3, 4, 5. Wednesday or Thursday? What did I say? So I said D, which is Thursday or Friday. Jeez, how'd I get there? Oh my. Okay. Quang, quang, quang. Right, okay. It's one thing to get something wrong because you did something wrong, but to get all the way to the very end of the race and then flop there is kind of weird. Anyway, I get C for this one. Right, and it's similar thinking. After 84 minutes, 8 candles have been lit. And at that point, the first 4 have faded after 90 minutes. So it's only then 40 that 4 of them that will reach the 90-minute mark. Okay. Right, next one. E. Okay. Let's see what they see here. The scenario would be equivalent to one athlete standing still and the other running at the combined speed. The distance between the athletes 1 minute before they collide is... Okay, so the combined speed will be 15 kilometers per hour. And then the distance covered in 1 minute is 250 meters. Well, that's interesting. That's an interesting way to think about it. It's warping my brain a little bit, but I think I see it. Right. So I got B for this one as well. They say, so they also extended, they kind of drew the triangles converging at the central point and said that each central angle will be 180 divided by 9 because there's 9 triangles, so 20 degrees. And then using the fact that it's an isosceles triangle, then you have the base angles being 80, so then the exterior angle will be 100. Okay, that's cool. That's cool. Definitely less hairy than my other bananas. And the last question, we got E as well. Okay, so note that the two chosen numbers must both be prime for their product to have exactly 4 factors. Not a bad effort. Not a bad effort. Not a bad effort. My grade 8 self feels validated by this bigger sister version of her. I struggled with Olympiads as a kid. Yeah, so amen. Shout out to the baby that tried, and shout out to me for doing a grade 8 maths Olympiad in just under 60 minutes. I will try to do a grade 9 one next. Let's see how that'll go.